Hello, everybody. Thank you for coming to our virtual presentation. This presentation is done by me, Lou, and Julia. And this afternoon, we'll be talking about factors affecting invasive rabbits in Australia. So to give you a little outline of our presentation, first we'll start off with an introduction into Australia's abundant bunny problem. And then we'll show you the research question that we posed based on the data set that we were given, followed by the methods that we chose to use to filter through the data along with the results that we came up with, followed by a short discussion on several other studies that we found about this problem, and we'll finish with a short conclusion on what we found from the data. So to introduce you to the problem, the European rabbit has quickly grown to become one of Australia's most widespread non-native invasive species since their introduction to the continent somewhere in the early 1700s. Originally, the rabbits were brought to Australia as a new food and hunting resource, but with limited predators and a fast reproduction rate, they quickly went from resource to pest. The rabbits have done significant damage to native Australian species numbers, as well as doing a lot of harm to Australia's agricultural industries. This problem was only made worse by the fact that originally there was very little collaboration between the levels of the Australian government, resulting in disconnect and unreliable data being shared between the different states or levels of Australian government. The solution that the Australians came up with to fix this problem was to combine more than 50 years of spatio-temporal rabbit abundance data into one database, the Australian National Rabbit Database, or the ANRD. Hopefully, this would give easier access and better analysis on the invasive species and begin to help the problem of combating them and getting them under control. So the research question that we came up with based on the rabbit data set was, which abiotic/biotic factors on the continent of Australia have the largest impact on rabbit abundance for a given region?
All right, so for our methods of analysis, we only used the abundance data set as it contained more useful information than the occurrence data. In the abundance data set, each row represents a measurement or observation. The different columns in the table represent variables or fields that were either measured or taken into account. In order to get this data into an appropriate format for analysis, we utilized the pivot table function in Excel. This allowed us to sift through the vast amount of data with more ease and pinpoint what was important. It also allowed us to efficiently visualize and make graphs that included many fields that we were interested in.
This first graph shows the rabbit abundance for all vegetation sites between the years 1981 to 2012. As we can see, the most abundant sites are sites 2, 3, 7, 8, 9, and 11. And so we decided to focus on these sites to see any possible trends that we could find. So this is just the same data, but with only those 6 sites that we're focusing our data on. So here's a correlation table, which shows the correlation between 2 variables at each associated vegetation type site. The results are from -1 to 1, +1, where anything near 0 indicates no correlation, negative numbers indicate a negative correlation, and positive numbers indicate a positive correlation. So this graph shows the rabbits and percent clay in soil relationship. So on average, there seems to be a negative correlation between the percent clay in soil and rabbit abundance. Most correlation values for this set of variables was between -0.4 to -0.6. High percent clay in soil notably see a low abundance of rabbits. And this is most obvious at sites 7, 8, and 9. So this graph shows the annual precipitation, annual precipitation with a 1-year lag and annual precipitation with a 2-year lag, with the average rabbit abundance per year. And overall, there does seem to be a negative relationship with rabbit abundance and precipitation, where large amounts of precipitation tend to result in lower abundances of rabbits. And this is especially noted between 1974 and 1980, 1986 to 1994, and 2002 to 2006. And this graph shows the average temperature of the warmest months with rabbit abundance. And here rabbit abundance seems to follow the trend of warmest months, especially when the temperatures are cooler than expected, where we see a dip in rabbit abundance with the decrease in temperature, such as in 1991 and 2003 to 2005. However, the increase in temperature from 1981 to 1983 seems to result in a reduction of rabbit abundance. And this is a similar graph, but with the average temperature of the coldest months, and as well as rabbit abundance. There is not as close a trend between the two as the previous graph, but periods of very cool years see a decrease in rabbit abundance in that same year, most notably in 1975, 1991, 2005, and 2010.
In order to better understand our results, we looked at 3 different studies that analyzed environmental factors and rabbit behavior or abundance. In this first study, they determined that the main driver for rabbit reproductive success was food availability, and the 2 environmental factors that influence this are rainfall and temperature. They observed that after dry years, the abundance of rabbits decreased and that their breeding season started later. In our analysis of the data, we observed a bit of a different trend in which rabbit abundance decreases the years where rainfall is high. This could be due to less food availability for these herbivores after extreme high or low precipitation, forcing them to delay their reproduction or reproduce in conditions that are not as ideal, decreasing their potential reproductive success.
This second study evaluated the relationship between rabbit warrens and soil composition. The study noted that rabbits seem to prefer sandy soil because of its low water holding capacity. So during flooding or heavy rainfall, the sandy soil allows for water to drain and not accumulate, where soils with high water holding capacity could reduce the drainage and accumulate water, which can drown the young rabbits in the warren. And in our results, we saw a negative correlation between rabbit abundance and percent clay in soil, indicating that the higher percentage of clay in soil, that there's less drainage potential, and that there could be an increase in young rabbit deaths.
For this last study, they did similar analyses to the first study we discussed. They wanted to see if their data made any connections between temperature, rainfall, food availability, and female fecundity. They observed that at low temperatures, vegetation growth and access to it are reduced, and it creates thermal stress for the rabbits, which delays reproduction, making the reproductive window shorter. So in colder years, we would expect to see decreased rabbit populations, and that is what we observe by looking at our graphs. It is clear that in the years where the average temperature of the warmest month is lower, rabbit abundance is also decreased. So overall, the factors we observed with the largest impact on the rabbit abundance in Australia for a given continent or given area was food availability to the rabbits. Food availability was most affected by environmental factors of temperature and precipitation, which can alter when food is available and for how long. Through analyses, we were able to observe that rabbit abundance seems to decrease with decreases in temperature, while precipitation was not as obvious of an influence. Some limitations we noticed were that vegetation growth data and information about reproduction and fecundity may have been helpful. These findings suggest that a way to control rabbits in Australia would be to control their main food sources so that the conditions are not ideal for reproduction. However, this could be difficult as it could lead to potential negative effects to the native species that use those resources as well. Our analysis was helpful in understanding dynamics between rabbit abundance and the variables we assessed. thank you for listening to our presentation. Do you guys have any questions?